Upbeat, mysterious music starts, then fades to a background hum. Hey everyone, and welcome back! Have you ever looked up at the night sky and wondered what secrets are hiding in the dark? Well, get ready, because we're about to dive into a story that's unfolding right now, millions of kilometers away. We're talking about giant, icy wanderers waking up from a long sleep and putting on a spectacular show. Today, we're focusing on a particularly fascinating one, Comet 3I ATLAS. So, what exactly is a comet? Imagine a giant, dirty snowball, a cosmic time capsule made of ice, dust, and rock, left over from the birth of our solar system about 4.6 billion years ago. Most of these comets live in the freezing, dark outskirts of our solar system, in a place called the Oort cloud. It's a vast, spherical shell of icy objects, so far away that the sun is just a bright star. They spend billions of years in a deep freeze, silently orbiting in the darkness. But every now and then, something gives one of these giants a gravitational nudge. Maybe a passing star gets a little too close, or they bump into each other. This nudge can send them on a brand new, epic journey, a long fall towards the heart of our solar system, towards the sun. And that's exactly what's happening with Comet 3I ATLAS. 3I Atlas isn't just any comet. This thing is a monster. Based on its brightness when it was first discovered, astronomers believe it can have a nucleus, a solid core, several kilometers across. To put that in perspective, that's the size of a small mountain hurtling through space. But what makes its journey so exciting is the transformation it undergoes. As 3I ATLAS gets closer to the sun, it starts to wake up. The sun's radiation, its warmth and energy, begins to heat the comet's icy surface. This process is called sublimation, where the ice turns directly from a solid into a gas, skipping the liquid phase entirely. This isn't a gentle process, it's a dynamic, almost explosive awakening. As these gases erupt from the surface, they blast dust and rock out into space with them. This creates a huge, glowing cloud around the nucleus, which we call the coma. The coma of 3I Atlas is enormous, potentially hundreds of thousands of kilometers across, even bigger than the planet Jupiter. It's this glowing coma that we see from Earth, not the tiny nucleus itself. And it gets even better. The solar wind, a constant stream of particles flowing from the sun, pushes this gas and dust away from the comet, creating its magnificent tails. Comets typically have two tails. There's the dust tail, which is broader, yellowish, and slightly curved. It's made of the heavier dust particles that are left behind in the comet's orbital path, almost like a trail of cosmic breadcrumbs. Then there's the ion tail, also called the plasma tail. This one is made of gas that has been ionized, electrically charged by the sun's ultraviolet light. This tail is thinner, often bluish, and always points directly away from the sun, blown back by the solar wind like a flag in a breeze. As the comet tumbles and rotates, jets of gas can erupt, making the tail shimmer, twist, and sometimes even break off and reform. It's a breathtaking cosmic dance. The story of 3I ATLAS is part of a bigger picture. Astronomers are realizing that many of these new comets arriving from the Oort cloud are unusually active. They seem to flare up dramatically when they're still very far from the sun, much farther than comets from closer in, like the Kuiper Belt, where Pluto lives. Why is this? One leading theory is that these Oort cloud comets contain supervolatile ices, like frozen carbon monoxide or nitrogen. These ices turn to gas at incredibly low temperatures. So, as soon as they feel even a tiny bit of the sun's warmth, they start to erupt violently. This initial burst of activity is what makes them so bright and easy to spot, even when they're beyond the orbit of Saturn. This is what happened with 3I ATLAS. It was discovered by the Atlas Survey System, that stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes in Hawaii designed to spot potentially hazardous near-Earth objects. But it also happens to be fantastic at finding comets. When they first saw it, 3I ATLAS was incredibly bright for its distance. Everyone got excited. Could this be the next great comet, a spectacle visible to the naked eye? Sometimes, however, this initial burst of activity is like a firework. It's brilliant, that can't sustain that level of intensity. As these comets continue their journey inwards, the most volatile ices burn off. The activity level might then stabilize or even decrease. In some cases, the initial powerful outgassing can be so strong that it actually causes the comet's nucleus to break apart. The stress of heating up and spinning can literally tear the comet to pieces. We saw this happen with another famous comet, Comet C, 2019Y for Atlas, a different comet, but also found by Atlas. It brightened spectacularly, and hopes were high. But then it disintegrated into a cloud of fragments before it even reached its closest point to the sun. It was a bit of a disappointment for stargazers, but an absolute gold mine of data for scientists. Watching a comet come apart gives us an unprecedented look at its internal structure. So, what is the fate of 3I ATLAS? Its journey is a high-stakes adventure. As it speeds towards the sun, it's in a race against time. Will it hold itself together long enough to swing around the sun and give us an amazing show? Or will the intense solar radiation and gravitational forces cause it to fragment, fizzling out into a ghostly trail of debris? Either outcome is a win for science, if it survives. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope can study the chemical composition of the gases in its coma and tail. This tells us about the raw ingredients that were present in the early solar system, the very stuff that eventually formed Earth and all the other planets. It's like cosmic archaeology. If it breaks apart, we get to see what's inside. Is it a solid, tightly packed body, or more of a loose rubble pile? How are the ices and dust mixed together? Every fragment tells a part of the story. Observing comets like 3I ATLAS is crucial. They are not just beautiful objects, they are messengers from the distant past. They may have been responsible for delivering water and organic molecules, the building blocks of life, to the early Earth. By studying them, we are studying our own origins. Every new comet that wakes up and visits us is a unique opportunity. We never know exactly what they will do. They are wild, unpredictable, and that's what makes them so captivating. 3-1 ATLAS is the latest character in this ongoing celestial drama. As it continues its plunge towards the sun, astronomers and amateur stargazers around the world will be watching, waiting to see what secrets it will reveal. It's a powerful reminder that the solar system is not a static, unchanging place. It's alive, dynamic, and full of surprises. Giant mountains of ice are waking up and making incredible journeys right now, painting a temporary, beautiful streak across our skies. So, the next time you get a chance, look up. You never know what you might see. Thanks so much for joining me on this cosmic journey today. If you enjoyed learning about the incredible life of a comet, make sure to hit that like button and subscribe to the channel for more deep dives into the wonders of our universe. And as always, keep asking questions and keep exploring. See you in the next video.